Hi, I'm Steve. You can call me Steve. I'm going to be 40 next year. I've been trying to deny it, but my eyes won't let me forget. As a chemist, I sometimes have to grow little crystals, and I have to look closely at them to see if they're growing properly. When I was younger, I had no problems doing that. Now, if I bring the violin this close, they go completely fuzzy. I vaguely alluded to how eyes work when I was talking about color blindness, and again when I was ranting about iridology. Your eyes somewhat resemble little digital cameras. There's a lens that focuses light onto a bank of receptors, which then use electrical impulses connected to a thinking machine to transform that into an image. In cameras, we talk about pixels and processors. In your eyes, the pixels are your rod and cone cells, and the processor is your brain. Let's start at the beginning. The first part of your eye that light encounters is the cornea. It's a protective membrane and a bubble of fluid across your iris. It's part of the focusing mechanism that resolves the images you see and also stops your eye goo leaking out your pupil. The pupil is the equivalent of your camera's aperture, which is just a hole. Likewise, your pupil is a hole in your iris, which is a ring of muscles that opens or closes to control the amount of light going in. Cameras have a similar iris-like structure, and so does the Stargate. Although in that case, it's not to control light getting in, it's to control Goa'uld getting in. Just past the iris is the other structure that focuses light, the lens. It's a transparent little disc-like structure that acts exactly like the lens of a camera. It focuses light onto a point. It can actually change its shape to help focus the image, which is something cameras can't do. If you look at a cutaway view of a camera lens, there are actually a series of individual lenses, then the aperture, and then a bunch more lenses. This is equivalent to your cornea, iris, and lens, but more complicated because the camera can't adjust the shape of any of its lenses, so it needs more of them. Your lens and cornea together focus the image of whatever you're looking at right on your retina, which is the lining at the back of your eyeball where all of your rods and cones are. Before the light gets there, it passes through the vitreous body, which is just a gooey, clear, semi-fluid that gives the eyeball its shape and stops it collapsing. Vitreous means glassy, so basically you're looking at the world through a blob of goo that's as clear as glass. When I talked about color blindness, I described how the various light-sensing cells on the back wall of your eye see and interpret color. I won't repeat that entire video, but I'll mention that you have 3 types of cone cells that see 3 different parts of the color spectrum, and rod cells that give you night vision, but don't see color too well. All of these gather the light of whatever you're looking at, which is converted to electrical signals in the nerves that connect your eyes to your brain. Your brain then processes all the incoming data and reconstructs the image. However, based on how we know lenses work, that image should hit your retina upside down. This means that during image reconstruction, your brain simply flips it right side up. Cameras will also have a shutter inside, which controls how much light enters the detection medium. Eyeballs have a shutter on the outside, eyelids. They're only similar in principle, not on operation, and the differences are way too nitpicky to get into here. So how come I'm losing my close-in vision? I was lucky as a kid because I never needed glasses. This is because the distance between my lens and the back of my eye was the correct length to focus the image right on my retina. If the length of your eyeball is too short or too long, then the image focuses in front or behind your retina, and as a result you see fuzzily. As you get older, it's very common for your eyes to lose their shape, which is why old people and glasses are a thing. This is what's happening to me, and I'm totally in denial about it. This misalignment is also why cameras and telescopes have focusing knobs, so they can adjust the distances between the lens and the imaging components to bring things into focus. Unfortunately, eyeballs can't do that, so we have to do what we can with glasses and contacts and laser surgery. That's eyeballs. They're biological cameras that let you see the world around you, as long as there's a light source. Incidentally, the complexity of the eyeball is not an argument against evolution, which will have to be the topic of another video. Thanks for watching. I've been Steve.